Okay, sup guys, so today I'm going to talk about salt preparation because it's a requested topic. So I'll just do a quick run through on it. Okay, so for salt preparation, you know that I like to teach by a flow chart because there are three different methods. Okay, and the first question I normally ask is if the salt produced is soluble in water or not. So if it's not soluble, immediately you'll know there is precipitation because the salt produced will be a precipitate, and we know that precipitates are not soluble in water, so immediately you know it's precipitation. But then if the salt produced is soluble, you have to ask yourself if both starting reactants are soluble. If one of the starting reactants is not soluble, you can go by adding excess, right? Because you can just filter out the excess reactant and then you get your new salt. But then if both starting reactants are soluble in water, you have to go by titration. Okay, soon you will notice that adding excess and titration method is actually very similar. Okay, that's why I have chosen to explain adding excess method first. So adding excess, the logic behind it is really very simple. Basically, you add the insoluble reactant in excess to use up the other reactant, which is the limiting reactant. So this reactant is added in excess so that you can filter it and remove the reactant, which gives you the remaining salt inside. Okay, so let me just explain what's up with this part first. Okay, so for step 1, right, you do it normally. Basically, you have a beaker of copper oxide and sulfuric acid. So we are looking at this example here now. Okay, so this reaction is going to go on, and at the end of this reaction, we are going to have an excess of copper oxide remaining in the beaker. Basically, the acid will be completely used up already. Okay, so whatever's left in that beaker is your copper oxide, your copper sulfate, and your water. Okay, whatever's inside this beaker. So after this step, you are going to filter it. Okay, you're going to filter it as shown in step 2 here to remove the copper oxide. So whatever's left here will be copper sulfate and water. Okay, whatever's left here is copper sulfate and water. Okay, and then after that, to remove the water, we will undergo crystallization, which is what you see at step 3. Okay, so you can see that this entire step is very simple. Step 1 is just adding, step 2 is removing the excess, step 3 is crystallization. That's it. Okay, for titration is just a little bit more complicated because you cannot go by adding excess method. Why you cannot go by adding excess method? Because both of the reactants are soluble. Okay, if both reactants are soluble, you cannot filter out the reactant. That's why titration is a bit more troublesome. Why? Because you have to measure the correct quantity of both reactants before you can react them. Okay, so you look here, basically step 1 and step 2, right? It is basically step 1 and step 2 is the titration method itself. Okay, so let's look at this reaction first. Sodium hydroxide plus hydrochloric acid to give you sodium chloride and water. Okay, so this is a neutralization reaction. Okay, so basically what we are doing here is we are putting a fixed amount of acid and a certain indicator. Okay, so a certain acid, which is hydrochloric acid in this case, and indicator. And then after that, we let the base titrate. Okay, basically titration is just letting the base drip into the reactant, into the acid here to react. Okay, so you let it slowly drip, drip, drip. And then once the indicator changes color, when the indicator change color, it tells you that this amount of NaOH is just nice already. Any more, there will be an excess of NaOH. Because why? A base has a pH of more than 14. Okay, when you have an excess of a base down here, what happens is it's going to push the pH level here up over 7. So when the pH level is over 7, this indicator will change color already. That's how you know that there is an excess of NaOH. So the moment the indicator change color, you stop this dripping, and then you note the quantities. So after you take note of the quantities of both the acid and the base that you are using already, you will repeat the experiment in step 3 with the same amount of the amount of reactants that you have noted in step 1 and step 2. Okay, so basically this step 3, right, is pretty much the same as adding excess already. Okay, it's just that you're adding not excess, but you're adding the perfect amount of both reactants. That's what titration is all about, because you cannot filter out the excess, so you put both correct perfect amounts of both components or reactants, okay, to get your salt that you want. So that's the difference between titration and adding excess. In adding excess, you add the excess of the insoluble. In titration, you add the correct amount of both reactants because both are soluble. The last method of salt preparation we have here is for an insoluble salt, which is precipitation. Okay, so it's used to prepare an insoluble salt, as the name says, precipitation. Okay, so there are two different types of methods as you can see here, but what I like you to know, right, is that basically precipitation is just an exchange of partners. You can see I've highlighted in red and blue, okay, the certain reactants, and then on the other side you can notice that both of them exchange partners. Can you see? There's a similarity in both different cases you can see here. So in one case you can have two soluble salts to produce an insoluble salt. Okay, how I like to make sure that my salts are soluble is that you remember your sparse salts are anything connected to a group 1 salt, anything connected to a group 1 metal, and anything connected to a nitrate is soluble. Okay, so just add a group 1 salt to whatever metal nitrate you want, and then you'll produce your insoluble salt. And this one you don't really need to care. Okay, just basically add a group 1 salt to a metal nitrate. That will give you the insoluble salt that you want. Okay, another case scenario you have here is a soluble salt plus an acid. Okay, so this one you have to take note because it's not as I would say it's not as straightforward. I prefer this one because it's easier. Okay, but this is really simple also. It's pretty much the same thing. Okay, the only thing to note is that you have to make sure that when this the cation of this salt merges with this anion of the acid, it must form an insoluble salt. Okay, so that's the most important thing to note. Okay, just add whatever metal you want to a nitrate to make sure that it's an aqueous solution, soluble in water, and then add to an acid to give you whatever you want. So here are the steps. You can see that everything I am having here is quite simplified. It's just to help you understand what's going on. So here is the two different types of examples that I'm having. One is two soluble salts together, and another one is a soluble salt with an acid. Okay, you can see that both produce the same insoluble salt. Okay, and the reactant at the end we really don't care because it's salt preparation, right? We just care about the salt. Okay, so as usual with the other two, you just add hydrochloric acid to a beaker containing silver nitrate here. So there's a reaction. Then after that, what you do is you just filter it. Okay, during this reaction you already notice a precipitate forming. That is the insoluble salt of silver chloride. After that you just filter it and then you get what you want already. Okay, so that's about it for this entire chapter. I hope that you guys understand. If you have any questions, just WhatsApp me in the group. Okay, I'll be replying to those questions.